Okay, let me ask if everyone has completed reading or in the middle of the reading. We may communicate by signs like completed, incomplete. Um, okay, yeah, thank you, Aaron. Maybe just a second. Let me suggest we start discussing, and maybe we'll start from the figures and captures by Aaron, and whoever left more comments may, or we will just informally go figure by figure and ask questions, and Aaron, if you want, you address them. Is it okay? Okay, so figure number 1, there are editorial suggestions from Amir. Thank you very much for very good eye catching all things. Yulun is asking why there are 2 sets of potential energy surfaces. Aaron, would you like to comment?
I guess because I did essentially like 4 sets of calculations. So I made 4 parabolas because that makes sense in my head how to organize the figures. And yeah, I guess that was the reason why I laid out the diagram in this way, because I did ground states and excited states, and then absorbed and desorbed configurations. So it's 4 possible configurations in total.
So is it correct that positive reaction coordinate means desorbed?
Yes, so it's like elongation of the surface bonds.
And intersection of the axis does not mean the 0 value. Of any of the
right.
So
they just represent barriers.
Okay.
But
yeah.
I guess my question is for the blue, if you go to positive x, what does it mean? What's the physical meaning?
Yeah, that's a good question. Because yeah, it wouldn't really be a parabola then, because there shouldn't be any restorative force. So yeah, the figure isn't literally true in some sense, but it's just the first approximation that I had in trying to describe all the calculations I'm doing.
So based on what Yvonne is asking, it sounds like a prompt to make the rightmost positive x wings of this curves more shallow and even being parallel to the x-axis.
Mm-hmm.
And then we approach to the question, if the desorbed configuration is still stable, since it has a minimum, it means it is desorbed, but still there is some preferred distance between desorbed ligand and the and the quantum dot. So it's not like freely floating away, but moving like in this coordination shell, maybe converting from the chemisorption to physisorption, but still like, is there really a minimum, or it goes completely as with the energy, like is there a minimum, or it will be continuously decreasing line?
I guess it mostly depends on how the coordinates is specifically chosen. But I guess there are like two extremes. So there is, like as you mentioned, like a possibility that it could be like in between absorb and desorb, like in the coordination sphere. And that would be essentially where the barrier is. So there is like a dynamic of going from absorbed to desorbed. And then in the like very far limits, it's the like the ligand or the molecule on the surface can float infinitely away. So yeah, the like the right end of the parabola should be more smooth or more flat.
Or maybe use something like Morse potential only for diagram. It doesn't need to be exact, but having this shallow or parallel to x-axis side may prevent some questions of the reviewer. You wouldn't thank you much for catching it. It's really deep question. Excellent. I have just cosmetic question about this delta barriers. Maybe one can indicate them by arrows for those lazy readers who do not read captions and just watch on the figures. Just make a little arrow targeting in this area, showing to the intersection point.
Yeah, that's what I tried to do with the like the brackets on the left hand side, because otherwise it gets kind of with lines going all over the place. But yeah, I can play with something to make it stand out more.
Okay. Further. So Yun has question why one is using radical notation in this labels.
Radical notation?
This letter R, like ligand is equal to R prime COO. The why the letters R are used.
Oh, I see. Yeah, so yeah, R would be methyl, then R prime is ethyl.
I see a possible answer that letter R takes less symbols than CH3. And in this work, computationally, one cannot take longer alkyl chains, but targeting the experimental audience, one can use, one can think of much longer chains. Ewan, would you buy this? Okay.
I guess because experimentally, if you use this kind of ladder, that means
anything. It is not necessarily alkyl chain.
Yeah.
So when we need to highlight that R symbolizes alkyl chain. Or it is what you were implying.
Yes.
Okay. And I'm keeping the same question in several figures. Would it be correct to say that this figure illustrates minimum of the red potential energy surface?
Yes.
Okay.
So yeah, that would be the two red parabolas.
Mm-hmm. Okay. Yeah. Yoon is asking why band gap is correlated. Why the correlation between gap and the angle is highlighted, and correlation between gap and distance is not shown.
Yeah, that's so ideally if it's fixed distance, like a fixed bond distance, then it would be like the angle would be the most important. But I guess yeah, Yulin is right that my distance isn't fixed for all the models. So there are changes in the average bond distances as well. Because I think the main idea is that like the like the overlap of atomic orbitals becomes less when you either elongate the bond or change the angle.
Mm-hmm.
So yeah, maybe Yulin's right that I should take expectation of the bond length too, and like plot that on the top axis.
Okay. I have a cosmetic question. Is it the panel D has red squares and all other figures have color code to show different wiggins? Would it be reasonable to make this red, green, blue?
Yeah, it can be done. I just have to
Mm-hmm.
fight with uprog to do it, but yeah, it can be done.
Okay. Okay. Yeah. Thank you. When I was doing my thesis, I didn't like GNU plot, or instead of finding a way to tweak GNU prog, I was opening a PostScript file and editing it as a raw code, looking where it defined the colors. But it is not right. It's much quicker to tweak GNU plot commands. I think there is only one question to figure 4. From it's a cosmetic question for myself, asking to confirm that this figure does correspond to blue potential energy surfaces in 1B.
Yes.
Okay.
So panel A would be the ground states, and then panel B would be the excited state.
Great, great. It is if one can communicate this connection to schematic diagram in the figure 1, it will substantially help the reviewer to see the logic, and it will make it like super clear in how it is organized. It doesn't change the scientific value, but it helps just to see connection.
Mm-hmm.
It looks like for the rest of the figures, everyone was happy, or no one understood it. I hope it was the first rather than the second. Okay, yeah. Many thanks to Aaron and to all authors of comments. Let's quickly go to the figures by Yun and discuss them, and then we'll complete the meeting for today. Aaron is asking, what is the unit kilobar? Is it? Are you asking how it relates to atmosphere, to normal atmosphere pressure?
Oh, BR is the abbreviation of bar.
Yes.
Oh, I've never seen it like that before. So
I'm not sure. Maybe one should explicitly put the A, like K bar, or I don't know. It's better to check. Okay. Amir is suggesting to chop figure 1 into multiple figures. Maybe if there will be several density of states and several spectra. But if
excuse me, I didn't suggest multiple figures, just split the caption, because all B to D are mentioned in a single sentence. So maybe we can have, for instance, caption B, C, or D.
Oh, okay. So just you're suggesting longer caption with more details.
Maybe, yeah.
Okay. Okay. Yeah. Thank you. Aaron is asking about panel D. What is the difference between red and gray bars? And there are two potential answers. One is that those are transitions originating from hydrogen and sulfur, and another is it is just lines used or not used for dynamics. So second, okay.
I tried to write something, but I don't know why it's not showing. But
Copy paste what you're writing. Maybe you can add it to main text. Just select some color for yourself, or you can verbally ask right now.
yeah, I was just saying, it's a small thing. Is the A is on the left side, and then B, C, and D are on the right side of the figure captions. So I don't know if you wanted to make them consistent.
Oh, you would suggest to move symbol A to.
Well, yeah, just make it consistent. That's all.
Okay.
But
yeah.
yeah.
Thank you for the suggestion. I also check, would it be reasonable to maybe plot orbital right here in figure B? Maybe not for the science, but for entertainment of the readers. And if we are going to discuss transitions, it could be reasonable to label them so that in text we can, instead of referring to transition energy, just call the like peak A, peak B, peak C. here I'm adding a comment. It is very interesting to see that first 4 snapshots evidently show sufficient amplitude to that exceeds normal lengths of the sulfur-sulfur bond, but it looks like different bonds are broken and reconstructed, which means it is like more dynamic oscillations rather than actual bond breaking. And maybe system has enough energy to exceed typical bond lengths, but it still will re-attract back until broken bonding is stabilized by protons. So first question from Aaron is, what is the role of hydrogen when d-sulfur fragments arranging into periodic structure?
I guess most of the hydrogen molecules are just spectator, but I guess some of them provides proton radicals so that the sulfur 2 molecules can be stable.
What is the approximately typical energy to break hydrogen molecule, to break HH bond? Is it something terribly high, or it is reasonable? I know from this molecular physics, I remember only one constant, that to decompose molecular nitrogen, one needs 6 electron volts. And I do not know this constants for other molecules. Maybe it is less. Maybe one needs to wait until one accumulates enough kinetic energy to break at least one molecular hydrogen into 2 radicals, into 2 protons. Aaron, does it answer your question?
Mm-hmm.
Aaron provides a hypothetical interpretation that sulfur ring fragments on smaller molecules S2, and they try to arrange into periodic arrangement. So, I did provide an answer that it seems to be more stable when it breaks not on S2, but S1 connected with hydrogens. Ewan, would you like to add comment, or it's enough? Aaron, do you need more comments, more discussion, or you think it is clear?
I think it's clear enough at this point.
Okay. And the goal of this work is to assist community to understand this high pressure hydrogen sulfide, because it is toxic and not super stable, or maybe there are some other reasons. Maybe it's easier to create it under high pressure just by creating it right in the cell for superconductivity. So instead of making a steel tank with pressurized H2S and then pressurize it further, one can just make this reaction in place. So I do have a suggestion which may or may not be reasonable. So by looking on this figure, it seems that for a long time there is no change in total energy, even when the bond is broken. But simultaneously, HS bonds are formed. So maybe breaking one bond and compensating another bond create a balance, and very approximately one can replace DFT calculations just by randomly creating a structure, counting number of bonds, and then telling if there are so many sulfur-sulfur bonds, so many sulfur H bond, and so many H bonds, then the energy will be this much. And by like taking available data, one can probably feed it into this equation, and then I'm not even if it is reasonable and if it is done, maybe it's not the biggest science for the globe, but it kind of logically wraps multiple data into simple.
Mhm.
So Aaron is asking if it is correct to say that when energy drops, there are periodic arrangements.
Yes.
Okay.
I have a few questions. Okay. So it's actually regarding figure 3 and figure 2.
Okay.
Both. Since you're kind of using the same frame number, let's just say on the last it says 1010 femtoseconds. Wouldn't you want to just have that as like the same figure? Because that way it's just showing the same like confirmation of the atoms. I didn't know if you had a purpose for why you're showing the same thing, but just a different view of it.
It's not the same thing. It's different things.
It is different. Okay.
One
So
is
what? Yeah.
hard
One is the.
trajectory,
Yeah,
one
go
is
on.
for coded trajectory.
Say that again. Sorry.
One is hard, one is cold.
Oh,
So
one is okay.
right here, I geometry optimize each snapshot.
Yep.
From the TTSMU trajectories.
Yep. 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 And then okay.
So
and then,
if what you were asking, if one would take the total energy without cooling, without optimization, then it would go almost as a line, approximately straight line with fluctuations increasing, going higher up and higher up.
Yep.
Because of the substantial fraction of the kinetic energy for moving atoms.
okay.
And it did sound like you had another question.
Yeah. I just maybe I would see it visually look better if it was like a straight line, and then you would only show like wherever you have your fragment showing, that would be like a box in that part of the figure. But I don't know. Maybe it's pretty consistent what you're doing with other papers. But. So like you have 7 different, let's say formations of the molecule here on figure 3. You'd only have like 7 boxes rather than all the boxes that you're showing.
Oh, okay. So let me check if I interpret the question of Mead correctly. He's telling, like, if we look on last 2 frames, there is an ambiguity. Maybe top atoms of the snapshot 7 and bottom atoms of the snapshot 6 can be intermixed. One can have ambiguity where they belong to. And Mead is asking if there is a visual way to avoid this ambiguity.
Well, I'm saying the red boxes that you see all the way along the line, just have the ones, because I'm assuming the red boxes are showing the snapshot, right? there's a relationship between that snapshot frame and then the fragment that you're showing. So like in the very first one, you're making it seem like the 8 sulfur atoms are, all connected, and it goes from 0 to 200. My understanding is just pick one box, let's say at the 100 mark, and have that as a square. But then everything else is a simple line. So rather than having like 100 red boxes showing, you'd only have one box for every one fragment that you're showing. So you'd have a total of 7.
Or this, as Mead suggests, or maybe in the stream of red boxes, add like 7 blue boxes or 7
Yeah,
black boxes that literally correspond to this configuration.
yep.
Yeah, thank you, Mead. Ewan, do you think it is helpful?
Yeah.
Okay. I have a silly question, which the answer is probably negative for this remaining figures. Is it correct to say that final product is independent on the way how the system was irradiated? Will it always arrive to the same product for any possible excitation and any schedule of if it is followed by cooling?
I guess I need to double check, but I guess they're pretty similar. So basically, you just have some independent sulfur atom,
Mhm.
and then they connected with each other through some hydrogen.
Okay. Basically, this question originates from the following thought. If and we need to wrap up in I really need to go, but let me share the thought very quickly. If you are thinking in terms of statistical sums, then like each box can be used to just to build statistical sum, and the systems that have a single ground state and systems that have ambiguity of ground configurations have very different properties, like in thermodynamics and in heat capacity. So they like if one can prove that for this size of the box and this number of atoms, the lowest like when all sulfurs are converted into H2S form only one ground state without ambiguities, it could be interesting fact to mention. I'm not sure that it is correct, but just so. Any quick questions? Then let's implement these changes, and maybe if some of us are working on last stage of figures, let's do third meeting on figures, but keep in mind that after that we need to focus on conclusions. And the reason to focus on conclusions is because it is a last chance to think holistically about the whole project. And if we write reasonable conclusion that connects all facts together, it will also serve as an organizational point for the rest of the materials. Then we can put all materials in the paper as arguments that will bring us to the given conclusion. Okay, many thanks. I will not stay here for one-on-one discussion. I have a scheduled conflict, but many thanks for contributions and have a nice evening.
Thank you. Have a good day.
Thank you. You too.